classification of NC systems. There are different criteria for classifying NC systems, that is numerical control systems. One is based on the type of machine or type. It is based on whether we need to regulate movement of tool. Okay, whether we are concerned about path of the tool or not. Based on that, so we have two types: point to point and contouring system. So in point to point, so we are worried about only the destination. Whereas in case of contouring, so we are concerned about the path in which the cutting tool travel. Next, according to the structure of the controller, so hardware based NC and CNC. Now NC machines are outdated. CNC is the existing technology. So NC was hardware based because here tape readers were used. So tapes were used. So in order to read and decode the information printed on the tape, so we need tape reader. Okay, so that is an additional hardware. So that's why it was called hardware based. Whereas now we have in CNC, okay, so you can connect a cable and you can communicate with some external device. You can send the program, or by inserting a pen drive, okay, or USB device also, so you can insert the program. So, but in case of earlier in NC, so for that we need a separate device. Okay, so that is an hardware. Next, so according to the programming method, so incremental and absolute. So there are two types of programming methods: incremental and absolute, based on what is the reference. Okay, so for while writing a program, so if you consider end of the previous step as reference, that is incremental. If you start from beginning, that is origin, that is absolute programming method. Next, based on the control loops, open loop and closed loop. Okay, so these are the classification, and we are going to discuss about this in detail. So first, consider point-to-point systems. So here we are not concerned about the path in which tool will move, or the path in which so we are going to move XY table. Okay, so this is suitable for drilling machine. Okay, where so if we are able to position the drill bit where we want to drill a hole on, okay, on the rectangular block or any work part. Okay, so that is sufficient. So we are concerned about whether we are able to position the drill bit to the required size. So we are not bothered about how we are going to achieve that. So anyhow, if we are able to position it, that is sufficient for us. Okay, so in that case we can go for point-to-point system. This is suitable for machine like for drilling machines. Okay, so here we are concerned about start point and end point, next point. Okay, whereas so here the path is not regulated. The path from the starting point to the final position, so is not regulated. The data for each desired position is given by coordinate values, and the resolution depends on the system's basic length unit. Next, there is a numerical. The XY table of a drilling machine has to move from the point 11 to the 0.63. So 1 and 6 are values for along direction X. 1 and 3 are values for direction Y. Dimensions are given in inches. That means these two are in inches. Again, these two values are in inches. Each axis can move at a constant velocity of 30 inches per minute. Find the traveling time between the points if the system's resolution is basic length unit 0.0001 inches. What are the incremental position commands to the NC system? Okay, here we have some data regarding initial point and final point or next point. Okay, so it will start from 1,1 and it has to move to 6,3. So that means overall along X axis it has to move for 5 inches. That means along X 6 minus 1 5 inches it has to move. Along y-axis it has to move for 2 inches, 3 minus 1, 2 inches. Okay, next. So now we know the distance it has to travel along x and y-axis. Along x it is 5 inches, along y it is 2 inches. Next, each axis can move at a constant velocity of 30 inches per minute. Okay, for both x and y-axis, velocity is constant, that is 30 inches per minute. First question is find the traveling time between the points. Suppose if you want to find traveling time along x-axis direction, we know distance it has to travel, it is 5. We know the velocity. Okay, now how we can find the traveling time? So if it can travel for 30 inches per minute, next what is the time taken to travel for 5 inches? So that is what we need to find. That means 5 by 30 will give you, so how many inches it can move per minute. Okay, so based on that we can find so traveling time. Okay, it is given by 5 by 30 and you will get it in minutes. Okay, if you want to get the value in seconds into 60, so you will get in terms of seconds. Okay, now you can understand traveling time of the x-axis. 6 minus 1 means, so it is the distance it has to travel along x-axis, that is 5 inches. Next, 5 by 30 will give you traveling time in minutes. Okay, if you want in minutes, so just 5 by 30, that is 6 minus 1 by 30 is sufficient. That will give you in terms of minutes. Okay, next, suppose if you want in seconds, multiply that with 60, you will get in seconds. 10 seconds is the traveling time along x-axis. Next, similarly, traveling time along y-axis is, so 3 minus 1, it has to move for 2 inches. 2 by 30 will give you traveling time in minutes, into 60 will give you in seconds. Now, so find the traveling time between the points. So if you, since it is a simultaneous movement, okay, so you have to consider the larger value. So one which is going to consume more time, so that you have to consider. That means overall time required to achieve movement from coordinates 1, 1, 2, 6, 3 is 10 seconds. Because 4 seconds simultaneously there will be movement for 4 seconds. Remaining 6. So one has to wait. Okay, so we have to consider the larger value. So that is, since the axis can be moved simultaneously, the traveling time of the table is determined by the longer one, that is 10 seconds. So here you are familiar with drilling machine. Okay, in case of drilling machine, we are going to position the we are going to do positioning. So by moving this XY table. Okay, whereas drill bit, so there will be movement only along Z. Okay, so before drilling hole, we have to do positioning. We will move XY axis. So this is a calculation related to movement of this XY table, on which we are going to place the work part. So you have to find out incremental position. That means if you are writing a part program, if you are preparing part program manually, okay, so then so what should be the value? So along x-axis, you should achieve movement of 5 inches. Along y-axis, you should achieve movement of 2 inches. Okay, that means for every single command, okay, for every incremental position, it can move for 0.0001 inches. That is the one incremental position. Like that, how many incremental positions are required to achieve movement of 5 inches? That is the question. Okay, for one incremental position, you are able to move the table along x or y axis for a distance of 0.0001 inches. Suppose if you want to move the table along x axis for 5 inches, so how many incremental positions are required. Next, similarly, if you want to move the table along y-axis, that is for 2 inches, how many incremental positions are required, that you have to find out. That is given by, so this again 5 by this basic length unit, that will give you the incremental positions. Again along y-axis, again this 2 by 0.0001, that will give you the incremental positions. Okay, like this. And next in the program, so again it depends on the configuration. If the configuration is 1 pulse will be equal to 1 basic length unit, okay, then you can make use of these commands. Okay, so the meaning of x plus 50,000 is 50,000 incremental positions will result in movement of 5 inches along x-axis. Then 20,000 incremental positions will result in movement of 2 inches. So that means within 2-inch movement, you are dividing 2-inch movement into 20,000 incremental positions, 0.0001, 0.0002, 0003, 0004, like that. There are incremental positions in between 0 to 2 inches. Okay, in between 0 to 5 inches, so there are 50,000 incremental positions. Next, contouring systems. The tool is cutting while the axis of motion are moving. So that means when you are giving feed, when you are feeding the work part, okay, the tool is cutting. Okay, this is applicable for which machines or which machining operations?
Lathe.
Lathe, then
and milling machines.
Milling machine. Okay, then shaping machine.
Yes, sir.
Okay, so for those types of machines, contouring systems are applicable. Okay, the tool is cutting while the axis of motion are moving. So in contouring machines, the position of the cutting tool at the end of each segment, together with the ratio between axial velocities, determine the desired contour of the part, and at the same time the resultant feed also affects the surface finish. That means here, in order to get required shape or required contour, okay, even the path of the tool also plays a very important role. Okay, so if there is deviation in the path of the tool, so you are not going to get the required dimensions. A velocity error in one axis causes a cutter path position error. The program feed rate has to be processed by the data processing unit in machine control unit. So in previous class we discussed about functions of machine control unit. It consists of data processing unit and control loop unit. So this is DPU, means data processing unit. So in order to provide the proper velocity commands for each axis, this is done by means of an interpolator. So we also discussed about the function of interpolator. It is going to do interpolation. Okay, so if you consider the previous problem, so in the part program we are going to give inputs as, so x plus 50,000, y plus 20,000, that is the destination, but this interpolator has to calculate in between values, okay, where it has to decide on the path in which the tool has to travel. Okay, so for that also there will be an equation there, or you can consider that as an algorithm. Okay, based on that algorithm, this interpolator will send signals to the drive. So this velocity error causes position error in the contouring system. So that means if there is a velocity error, so instead of moving the cutting tool in this path, okay, so it may travel in incorrect path. Okay, this is the error. Interpolator function can be illustrated by considering a two-axis system where a straight cut is to be made along the path as shown in figure. Okay, this is the path along which so a cut should be made. That means cutting tool should travel in this path. assume that the x-axis must move p units. So this is the p units along x-axis, and at the same time y-axis moves q units. So this is the coordinated movement. The contour formed by the axis movement has to be cut with a feed rate of v length units per second. It may be in millimeter, in meter, in centimeter. Okay, so that is feed rate. The numerical data of P, Q and V is programmed on the tape and is fed into the interpolator. Okay, the interpolator are the inputs to the algorithm or equation of the interpolator. So will consist of these values of P, Q and V. V is the feed rate. So P is the values along x direction, Q is the value along y direction, distance. Okay, it has to travel. Based on that, so these are the equations. The interpolator will then provide velocity signals in a pulsed form proportional to this value. So this is along x-axis, this is along y-axis. Velocity signal for x-axis, this is velocity signal for y-axis. It depends on distance it has to travel, then feed rate. So then p square plus q square, this is nothing but this is the path. Okay, so or this is the path in which the tool has to move. So if based on the Pythagoras theorem, okay, this is a right angle triangle. So if you want to get this, okay, based on Pythagoras theorem, okay, so this will be the hypotenuse. So you know, so Pythagoras theorem, based on that, so you will get this. Okay. So this will be P and this will be Q and this is the hypotenuse. There is one more problem related to this. A MC milling machine has to cut a slot located between the points 0, 0 and 7.1 inches on the XY plane. The recommended feed rate along the slot is 6 inches per minute. Find the approximate cutting time and the axial velocities. Okay, this is the given question. Axial velocity means, so you have to find out Vx and Vy. For that you have these equations. Okay, or even interpolator will send signals by executing this equation or these algorithms. Okay. Next, in order to find approximate cutting time, first you should find the distance traveled. Okay, so here distance traveled is nothing but this is the path which will give distance traveled. Okay, so that's why you are considering. So distance traveled along x-axis direction and along y-axis direction. So this value and this value. Okay, and root of squares of these two will give you this value based on Pythagoras theorem. Okay, then so here you know along x-axis it has to move from 0 to 7.1 inches. Along x-axis it has to move for 7.1 inches. Along y-axis also it has to move for 7.1 inches. So 7.1 square plus 7.1 square, then root of that will give you this answer. So you will get this value if you substitute 7.1 for delta x and delta y. Next, after that, so you will get distance traveled. Okay. Next, distance traveled by this feed rate, that is 6. Okay, L by 6. So you will get cutting time in terms of minutes. If you want cutting time in terms of seconds, then multiply it with 60. Suppose if you want to keep it in minutes, so just L by 6 is sufficient. Okay, that will give you value in minutes. So if you want to convert that into second, multiply it with 60. Next, so for finding axial velocities, you have these two equations. Okay, substitute the value of P, Q and V. Okay, P and Q values are same, 7.1, 7.1. Okay, then V value is 6 inches. If you substitute that, so you get this answer. Since P and Q values are same, Vx will be equal to Vy, and you will get this value. Next, straight cut systems. So this is also contour system, okay, and it is applicable for shaping machine. Okay, so contouring control is done from point to point, but you are concerned about path in which the cutting tool will travel. Okay, so that's why even though it is between point to point, but you are concerned about the path also. Okay, it is also part of contouring system. Cutting tool can move only along straight lines which are parallel to the main axis of motion of the machine tool. Example is shaping machine. Next, NC and CNC. The trend away from hardware-based MC to software-based equipment brings an increase in system flexibility and an improvement in the possibility for correcting fault programs using the CNC computer. Okay, if you compare earlier days where we were using CDs and these tapes, okay, for storing information. Okay, so compared to that, okay, the tools which we are going to use now, devices which we are going to use now, so they are more flexible. Okay, so even compared to pen drive, okay, so storing data in CD, and again if you are reusing that CD, that is problematic. Okay, so here also in NC, so tapes were used. Okay, comparatively they are less flexible than the techniques which we use now to feed programs to CNC. Okay. Next, so there are few aspects related to CNC. The digital controller in hardware-based NC systems employs voltage pulses. So that means in order to drive, in order to get movement along any direction, X, Y, Z, okay, you need to give input to motors. Again, motors, the signal input to the motor will be an electric signal in the form of pulses. Okay, that is the meaning. The digital controller in hardware-based NC systems employs voltage pulses, where each pulse causes a motion of one basic length unit in the corresponding axis. The meaning of this is in NC systems, when motor receive one pulse input, that will result in a movement of one basic length unit. If the basic length unit is 0.0001, if you give one pulse input to motor, that will result in a movement of 0.0001 inches along X, Y, or Z, depending on the drive of which axis is it. Okay. In these systems, a pulse is equivalent to one basic length unit. The meaning of this is, if you give one pulse input, that will result in one basic length unit movement. So in the computer, the information is arranged, manipulated, and stored in the form of binary words. That means in the language of zeros and ones. Each word consists of a fixed number of bits, the most popular being the 8-bit and 16-bit words. In the CNC computer, each bit represents one basic length unit. That means in order to store one incremental position, one bit is required, one bit memory is required. If you want to store 1000 incremental positions, so then 1000 bits are required. So if you want to store 50,000 incremental position, then 50 bits are required. That is the meaning. So in order to store one incremental position, one bit is required. So thus, this is an example. A 16-bit word can, for example, represent 2 power n, that is 2 power 16, and it can store. Okay, suppose if it is a 16-bit register, so you can use a 16-bit register to store 65,536 different positions. Okay, that means you can store, if you are using 16-bit register, in that you are able to store 65,536 incremental positions. That is the meaning. So if the system resolution, if for example, if it is having basic length unit of 0.01 mm, this represents motions up to 655.35 mm. That means if you are using a 16-bit register, then the capacity of that 16-bit register is, it can store up to 2 power n, that is 2 power 16. N is the number of bit register it is. Okay, so it can, that is 65,536. The meaning is it can store 65,536 positions. Okay, it will start from 0. It will also include 0. So now, so if you want to know to what extent it can store, okay, so it can store based on this basic length unit 0.01 mm. It can store movement up to 655.35 mm. That means, so 0.01 mm is one incremental position, 0.02 mm is second incremental position, 0.03 mm is third incremental position, like that from 0, okay, till 655.35 it can store the values. So from 0 to 655.35, that includes 65,536 different positions, where 0.00 is one position, 0.01 is second position, 0.02 is third position, 0.03 is fourth, 0.05 is fifth, like that. This 655.35 is 65,536th position. Okay, that is the meaning. Next, overall, in conclusion, so what we can say is 1 bit will be equal to 1 pulse, and that will be equal to 1 basic length unit. The meaning of this is, in order to store one incremental position, that is 1 basic length unit, you need 1 bit memory. And again, in order to achieve a movement of 1 basic length unit, so you need to give an input of 1 pulse to motor. CNC systems can be designed in different configurations. The simplest one, this is one such configuration. Okay, this relation may be different depending on the configuration. Okay, CNC systems can be designed in different configurations. The simplest one, denoted the reference pulse approach, emulates the hardware-based NC and transmits out pulses as well. Therefore, in the system, so it will work like this. Next, so I think so for you it may not be visible. Okay, later I will type this and I will share. Okay, so in the study material I will type this. Now I will explain. The required axial positions are stored in CNC systems in software counters contained in the control program. If the maximum allowable position in a system is 9.999 inches and the basic length unit is 0.001 inches, how many counter bits are required? Okay, so now, so you need to make a decision regarding, so what should be, how many counter bits are required, whether it should be a 6-bit, 16-bit, or whether it should be a 8-bit counter, or whether it should be a 4-bit counter. Okay, like that. So you have to calculate. So now, in order to calculate, so how many bit counter or register is required? First, you should calculate the number of incremental positions. Okay, now, so you need to store movements up to 9.999 inches. Okay, from 0 to 9.999 inches. It may be along x-axis, y-axis, or z-axis, that we don't know. In any axis, if you want to store movements from 0 to 9.999 inches, well, that means starting point to destination. Okay, if there are, if the distance is 9.999 inches, and if the basic length unit is 0.001 inches, next you should know how many incremental positions. That will be given by 9.999 divided by 0.001 will give you, so incremental positions. Now next question is, in order to store this much incremental positions, how many counter bits are required? Okay, so that for that you are going to make use of that equation of 2 power n. solution is, so first you will find out, so this, okay, how many incremental positions. So that will be given by 9.999 by 0.001. So you will get number of incremental positions. So incremental positions required are 9,999. Okay. Next, so the capacity, since it also includes 0. Okay, so it should be greater than 2n. Okay, so this value should be less than 2 power n. Okay, so 2 power n should be greater than this value, because 0 also should be included. 0 is also a position. For that also 1 bit is required. Okay, now so use this equation. 2 power n should be greater than 9,999. Next, apply log on both sides. Okay, then it will become log 2 power n greater than log 9,999. Okay, next, so log 2 power n can be written as n log 2 greater than log 9,999. Then you can send this log 2 on left hand side to denominator. Then you will get this equation. Okay, so all these are fundamentals of mathematics. Okay, so all this we are familiar with. So using that we can find number of bits counter required. Okay, so the number of bits required is 14 bits. So in order to store, the meaning of this is, in order to store 9,999 incremental positions. Okay, from 0 to 9,999 incremental positions. So you need 14 bits counter. Okay, so that is the meaning. So you don't get 13.3 bit counter or 13.3 bit register. You should round it off to 14.